Hi, everyone. You might have seen some of my talks before on some of my projects. I'm basically going to do all of them in this. This is one project, basically, that brings it all together. And it's kind of the kind of thing I've been wanting to work on for a long time, which is procedurally generated soundtracks for games, both on the music side and on the sound effects side. So what I've been working on recently is some technologies and some workflows to make basically the opportunities a bit richer for more immersive soundtracks that react to game and to move away perhaps from the use of sampled and recorded audio for games without necessarily losing anything in quality. So the plan is such as it is. Say hello. Hi. Done. And I want to get a slight feel for the audience as well. So are you in game audio, industry professionally? Who's a C++ developer? There we are. Who's a musician? Who's a gamer? Oh. Right, cool. Who's used Unity or Unreal? That's interesting. Right. So what I'm going to do, I'm going to rant a little bit about, game sound is great at the moment, but we could be doing more with it. And what's great at the moment is the quality of it, and you can have orchestral and epic scores and things like that, but they're not necessarily that closely related to what's going on in the game. So I'm going to basically talk about procedurally generated soundtracks, both in terms of the music for a game, and in terms of the audio for a game, so the sound effects as well. And in each case, I'm going to go through kind of some general concepts, some techniques. So I'm not going to kind of teach you to suck eggs. I still don't know what that means. But I'm not going to go through the kind of traditional methods too much of kind of layering audio and things like that. I'm going to try and introduce you to some kind of novel schemes that I've been working on where the soundtrack is actually part of the gameplay. I'm going to introduce two technologies, basically one for music and one for audio, which you might have heard of before. Manhattan is basically a tracker in disguise, but it looks like a musical spreadsheet, so I added formulas. And that's really great for dynamic soundtracks. And then the other one is going to be Klang, which is basically a way of using C++ for audio and expressing audio in a more kind of audio-friendly language. And especially what that does is it allows you to express signal flow. So certain projects that might have been done in applications such as Pure Data or Max is now that much easier to actually express in C++. And so how many people have this book? Yeah, quite a few. Okay. It's a good book. I'll talk more about that in a second. So we're talking about Manhattan. I'll demonstrate this through a game called Ars Arcus, which is downstairs, and you can play it. And it's just a test bed, basically, for procedural game music. And that's developed in Unity. So these technologies integrate with middleware, common middleware. And then to explore procedural audio, we'll go through the same kind of things. And we'll look at how Klang is used to do procedural audio, so to generate and synthesize the sound effects themselves. And this will be demonstrated through an Unreal game, which is the future sound of Bristol. So I think you probably caught that in the talk description. And it's a slightly bigger game than the other one. It's actually 3,000 times the size of GTA 5. So, yeah, that's quite a lot. And hopefully, I do tend to run on, but hopefully there'll be time for discussion and questions because there is a lot to talk about in this subject and a lot of opportunities to do new things. Right. So yeah, I do a lot of things. I have a lot of hats, but I've got kind of the music perspective as a composer, but also the developer's perspective. A lot of my experience and my kind of experience of technologies and of people using technologies is not only from industry, but I work in academia as well, and I try to teach audio programming and make these technologies more accessible. And I think what we need is technologies that are advanced, but also accessible to musicians and practitioners so that they can be the ones using it and you don't get the division of labor and aesthetic. So one of the big things basically I've done recently is pull all my projects together and establish a non-profit organization, which is basically just there to lose money and give stuff away. So yeah, so all of these projects basically are generally for free, although I'm a non-profit, not a pro-loss organization. So if anyone has any ideas about how to monetize these things, that would be great. Or they want to just give me a gob of cash, that would be great too. Right. So this is kind of, over a career, I've just kind of gelled on this kind of way of modeling music, which is music are patterns, quite often repetitive patterns, but they change over time. Okay, all music basically requires patterns. You organize sound to produce music, and then we change those patterns to develop the piece, but quite often, in subtle ways or in big ways, and that leads to emotion and things like that and all the good stuff, and shivers down your spine. But broadly, what we're talking about is either perceiving music as data or as a function which changes the data. So if we think about the interfaces that we use as either musicians or coders or somewhere in between, you've got a piece of software that treats music as a pattern and you put notes on a page, or you've got a piece of software, a programming language, which allows you to write a process. And yeah, as we'll see, never the twain shall meet. So it's basically patterns of notes, basically. That's what MIDI is, that's what sequencers offer you the opportunity to do, and so forth. Super. We arrange the notes in a kind of structure. MIDI is a big influence on how we express that digitally, and of course, we have sequencers. So sequencers are the kind of leading model of computer music and writing game music and things like that. So great, yeah, close the circle, it works nicely. Let's go to the other side. This is audio now. So we're treating the patterns of sounds and samples and things like that. And kind of the things that we do is we record them, we mix them, and underneath it's digital audio and samples, and that's really, really low level. And okay, on that side of the slide, these all come together basically in the door. Okay, the door is basically this collection of tools, not necessarily all tied together coherently, which allow us to arrange patterns and things like that as basically static structures. Okay, so a piece of music is bounced, put on a CD, just showing my age there, put on an MP3, still showing my age. Right, so there's not enough catering for process in kind of end-user music apps. So how do we do process as a way of expressing music? Well, it's all about, on the audio side, we do have technologies for this. It's all about thinking about signal flow and coming up with the data flow languages and things like that. We can do synthesis, we can do effects, and we can live input and respond to live input. And basically, the way we interact with that is through some form of programming language, and that might be text-based, or it might be visual, graphic. And there's, on the audio side, there's actually a rich plethora of different options, which you cannot read because it's too dark. Max, Faust, Reactor, Pure Data, Super Collider, or if you want to go hardware, modular synths. So pretty well catered for there, but there's relatively few people on this side also doing this side. So what about if we go over to the music side? Okay, what's the abstract thing that, I don't know actually, I don't think we really have a word for it. It just kind of reveals this kind of gap. I think the least worst option we might call this side is control flow, okay? But we have this issue basically where it's all stream driven. It's all data flow, it's all living in the now. And music is a lot about what happens over time. And so the richness of how you represent time kind of defines what you can do with music. And so in a kind of data flow and control flow environment like Max or the kind of like other kind of programming languages for music, kind of addressing past events is really difficult, or just writing out a phrase manually rather than have to write it out as an array or something like that. So actually, what we have is a bit of a disjunction between the two sides in many, many ways. And there are fewer music programming languages as well. And they tend to be the purview of academics and experimental musicians and things like that, because it requires a certain amount of expertise. But what we're fundamentally talking about is on that side, we've got static representations of music. And on this side, we can only really represent change. So this is the dynamic side, but it's harder to represent the static bits. So, kind of maybe there's a continuum between the two of them. The linear timeline of a DAW and such apps is a really powerful way of basically, and an important concept in writing music traditionally. If over the centuries, music has almost always been written down on a timeline of sorts, which doesn't really exist in many of the programming languages we have for audio or music. So I don't know how we can translate legacy traditions to these new technologies, because they're based about live streams. Okay, living in the now. That makes them fantastic for handling real-time situations. And you'll find a lot of these technologies on the right, they're great for live performances and sonic arts and kind of interactive things. But would you write a symphony? Would you write a pop ballad in any of them? It's difficult to do things on the other side of the fence. Right. But because of that, there's also a kind of separation between the people, okay? Coders, and the end users are over here. And that's not just important, it's not necessarily in terms of smart people and dumb people. These are coders, and these are experts in other fields, such as music. But, we are basically in the room where you've got the intersection of these skills. And basically, you go outside this room, and that intersection doesn't really exist. Okay, one of the big things is, if you think about what an end user program is, you're interacting with and looking at the data. You can see the data. The process is the code beneath the program, and you can't really see it. Whereas if you're coding, you write the process, and the code represents the process. But you can't see the data because that's in memory, okay? And we don't visualize memory. And one of the big things I'd say that people are starting to learn now in developing programming languages for audio is the importance of visualizing what's going on and what the result of your code is. But that is one of the reasons why this is inaccessible to an end user, because you literally cannot see the music or edit it. So you do tend to find that, this is kind of slightly more experimental, academic, and in regards to aesthetics as well, and the kind of music you can represent, you can write, a DAW can basically be used to transcribe any style of music. Whereas code, it kind of suits specific styles that suit process-oriented composition styles, especially minimalism, also known as process-based music. So, and these are all very pretty graphics, aren't they? I love gradients. So, but it's lying to you, because you're kind of like, this is a gradient. It's suggesting that there's a continuum between the two of them. And the reality is, not really. Okay, you have software that's really good at patterns, and you have software that's really good at processes. You've got your end user software, and you've got your programming language software. And that Goldilocks zone in the middle is occupied by there's very few options there. And they tend to be informed by one side of these disciplines. So, let's have a quick look at the state of the art. So in game audio is actually a really good example, because that is the intersection of we need music, and we want to be able to represent music that is familiar to people, but we also want it to change because the game's context changes, and we don't know how late in the morning they're going to be playing to, so we don't know how much we need to write. So these are technologies that are overwhelmingly inspired by DAWs and kind of studio and production processes which allow the users to transfer their knowledge from traditional ways of music making and production into games And it also does ensure that you get an exceptionally high quality of audio and production value. So they do have the linear timeline because DAWs have the linear timeline, but they also put in data flow logic so that you can basically move about on that timeline and you can have nonlinear music that responds to your game. So this is great. This is awesome. There's a recent move towards having a bit more procedural generation, both on the audio and the music side, but we're still very heavily based on the assets in a game soundtrack being the audio file, okay? A frozen piece of music that is hard to edit and saying, yeah, okay, I want to make that an octave higher, or I want to detune it, or I want to move it from major to minor. Oh, in that case, we have to make 100 different assets. And if you've done game audio in your room, you know that this is absolutely the worst part of the job and where everything goes hideously wrong. And overall, we're talking about an interface that is oriented around the DAW and the sequencer. And the real strength of that is that timeline, I think. So what you get from that is professional audio quality. You do get some basic generative features, but they can be limiting. We're going to look a little bit more at what data flow languages, how they are to interact with as a kind of creative person or even a coder. And they can be cumbersome at times. And their cumbersomeness makes it difficult when you start to get a really complex patch or whatever, it becomes unwieldy. And so that basically different programming languages are defined by their usability. And VPLs are great for prototyping and making things accessible to new users, but they don't scale particularly well, and you have to use a bloody mouse. So one of the key things that you might know, or notice now, is we don't really have note level access. We can do things with sound, and we can generate notes in real time and things like that, but we just can't say, oh, take that first note from 4 bars ago, unless we code the facility for that. So there's still a bit of a disconnection between the two sides. Right. On the audio side of things are pretty good. Pure Data obviously has a really great track record in supporting procedural audio for games. We actually have one of the Spore developers in the room, where the soundtrack was actually developed in Pure Data, working with Brian Eno. So that was great, but that, Brian Eno's ambient style that you can kind of reduce to patterns and processes quite easily. Still a fantastic soundtrack. And of course, we've basically got the updated version of that. So Unreal are now added meta sounds, which is the same broad thing. So I think there's been a step change. The kind of oscillators and things like that are slightly nicer in quality. The interface it has color, and that's definitely good. So it's a data flow programming. It does audio signal processing, and it's very good at this. You can basically do anything in either environment in terms of synthesis and effects. And both of these, this is game middleware, and this has been integrated with middleware countless times. It's very, very easy to put a pure data patch inside any C program. So yeah, they work quite well, and you can kind of fuse the two together. There's a good interplay with kind of Unreal blueprints and C++, and it kind of when you start using a VPL with C++, it's harder to see the equivalent sometimes. But they are stream-driven, and there's no real explicit timeline, again, which is not too much of a problem for audio unless you really do actually want to know what the sounds were half an hour ago. And it's live real-time programming. This is a real benefit. So this is as a creative professional working on sound, what these environments offer you is the ability to hear the sound as you create it. And the power of that can't be underestimated. And if you think about how else you might go about doing sound in a game, you might be writing in C++. The feedback loop there is a bit slower. You kind of, I have to rebuild it, or even you've got live build in Unreal, but it can be, a slower feedback cycle, so you feel less immersed in the sound design process. Yes, these technologies, they've been an established legacy in procedural audio. So this book here, for those who don't have it, is a great book and basically is the Bible for procedural audio. And explores the concept, and generally the approach, but also specific sounds through pure data patches, basically. And they're all available. You can download them, and they produce car sounds and rain sounds and things like that. And we'll talk about its place in history, which is hopefully not over yet. These are basically, the emphasis is on sound here. You can do music in both of these languages, and definitely here, but it is still very much a process-based mentality about music rather than thinking about, melodies and motifs and harmonies and things like that. So it's still difficult for a musician or, people in other genres of music to kind of like, oh yeah, I'll put that in the game. And it's all visual programming languages are will be at scale. And one of the key things I like about text-based programming languages, they can basically do it without looking, and my fingers do some of the thinking. And that doesn't happen with visual programming languages because you're always looking at it and you're always kind of like, oh, where do I need to click now? Double click, yes, okay. So yes, and you end up with RSI. I've been working a lot in pure data recently, and it is brilliant. It is absolutely amazing, seminal piece of software, but the kind of generators and things like that in it are not the best quality, and sometimes you really have to dig through the reference manuals to find out, what the hell type of filter is this? Does anyone actually know? That is something, hopefully, this will be a little bit more predictable and well documented. The one thing about PD is the community, which is pretty amazing. Right. Rant over. Let's now focus on procedural music. A brief history. It started pretty good, actually. In the 8-bit era, 70s and 80s, computers were so crap. They couldn't use samples. And everything had to be ridiculously efficient. So the music was run by sound chips on the device, and the tools for the job were development tools. So you had composers who were coders, and they wrote music as code. In a lot of cases, they were still classically trained composers, but they just learned basically how to code their music. And as a result, there was a very close connection between the game and the process, and it was being generated as it was, as you play the game. So actually, there's a hell of a lot of dynamism in the soundtracks, even if you go back to like the 80s and the 70s. And a name that certainly people of my age know for lots of wonderful computer games, but because of its contribution to procedural music, is LucasArts, basically. George Lucas has always really valued the role of sound in all media. This is 50% of cinema, and that translated to the games they made. So you'll see basically LucasArts and the iMuse system especially being very influential in how we approach music now. But I want to introduce the actual hero of this story. Anyone have an Amiga, or is that just me? Yay. Right, so this is a really old computer. A 16-bit computer, had a whole 0.5 megabyte of RAM. But it could do 4 channels of digital audio, and it could mix them on the fly, and you had this type of software developed for it called a tracker. And what it allowed you to do is to create musical patterns which were sonified using samples. And you could use any sample you like. So you had a kind of step change in the approach to not just notes or beeps and things like that, but we could take real instruments and sample them and so forth. And they were incredibly efficient. So mod music, as it was known, that's the file format. Basically, all the games on the Amiga were in mod music, and actually quite a few of them in the early DOS days. And a notable user of mod music and trackers was Epic Games. So Unreal, the first game, and Unreal Tournament both used tracker music for their soundtracks. I really enjoyed them. And actually, in Unreal now, you still have native support for tracker files and so forth. So still knocking around. Right, let's just park that. It'll return in a bit. Fantastic game. Monkey Island 2 introduced something called the iMuse system, which is LucasArts basically, it's sequenced MIDI patterns as you played the game and reacted to how the player moved around the world, which was, a pirate adventure story on an island. It was interesting as there's no audio involved here. You had to have your own MIDI synthesizer built into your computer. And there's a special art to making an arrangement sound good on all types of MIDI synthesizer. But yeah, it was an exciting moment. And actually, a lot of the techniques that were developed for iMuse shaped the middleware we have now for game music. So things like Fmod and WYs do a lot of this, offer a lot of the same functionality that iMuse did with MIDI. They just do it basically with stems and audio. And a little known fact, the mod in Fmod is this. So it's actually a mod file from a tracker because the first version of Fmod, it stands for Firelight Mod Player. It was literally just a software player to play tracker files. And a few years later, it started to become the middleware for games. And there was a way of using it so that you could still use tracker files because they already on the Amiga had established that because the tracker files, they were based on patterns. And so you play one pattern and you could choose the order of the patterns and which one follows which, as it plays. So it was really great for adapting to games. And so it made its way into a lot of games. And it's still knocking around. It's still in the code base. And I love the fact that it's still in the name too. Right. The trouble is, though, it has set the tone, basically, for how we approach game music now. And that is very much that DAW sequencer approach. It's very much about having really high quality audio assets that are really ingeniously kind of combined, layered, processed, and then played back. And from about, the noughties, in the late 90s, we started leaning towards audio rather than real-time sequencing or generating of music. MP3 was rising around this time, so we could fit a lot more. But you also even had some games from earlier that just kind of like had CD-ROMs, extended CDs, which basically had a data track and then a CD audio that was the game soundtrack, and it would just play a CD while you were playing the game. And so we've regressed to a very linear way of thinking about music. But that is not to say that Fmod doesn't offer a wealth of ways to kind of spice that up. And the trouble is, it does it well enough. And it sounds good to all players generally. But there are a few people who thought, yeah, it's kind of a bit repetitive, it's more like background music than it is anything to do with the game. So there have been a few kind of examples of people trying to be a bit more ambitious. And there have been some music games which have been basically where interaction has driven the soundtrack. So there's Electroplankton on the Nintendo DS in 2005, which is a music game, and Spore itself. So Spore itself was a procedurally generated game, and it basically, that ethos pervades the design of the whole program. So the soundtrack was procedurally generated, and the sound itself as well, I think. We're not quite sure about that. So what else? Spore and another procedurally generated game. Okay, and it is a little bit of a move towards this and a reignition, of this interest in procedural generation. But No Man's Sky was actually eventually a really good game. Actually procedurally generates an entire universe as well as the soundtrack and the species and things like that. The trouble is that these are the exceptions to the rule, and that most other games are more or less playlists, and sometimes literally playlists. So Grand Theft Auto 5, for example, you're just listening to a radio and tunes on the radio. So yeah, there's a gap at the bottom. And I don't know what's happening next. There is some moves in the middleware to kind of try and get people to be thinking about procedural generation. But at the moment, we're still thinking about doing it with data flow languages. And it might limit us musically. Okay. This is a tracker. This is Impulse Tracker. I learned a lot about music on this tracker in the 90s. But this, it's been used in a lot of games and productions. And basically, yeah, it just treats it as a grid. I mean, it looks a lot like a spreadsheet, which obviously really appeals to musicians. One of the things I tell my students, because I teach my students a form of this interface, and they kind of like, these days especially, they come in and say, it's like matrix code. How do you expect me to read that? And they start coding, or they start messing about with it, and because they can put in a note and then instantly hear it and instantly get feedback on what they're doing, I think the realization, and everyone comes to this point, it looks hard, but it isn't. And that's because of the feedback loop. But that other thing, that kind of, it looks like a spreadsheet, gave me an idea. What if we put formulas in the cells? So that's the main idea behind Manhattan. Okay, it is a tracker. You can put notes in the cells, so you can manually sequence music to your heart's content, or you can put code as musical events in the score, and it gets executed as that cell gets played, so the piece changes over time. And I just did this on a whim over at Christmas at one stage, and I thought, yeah, see what it does. It's enormously powerful. And what it does is it gives you access to the whole continuum of procedural music, from completely sequenced stuff to completely generated stuff, and however much code or music you want to use in the middle. It doesn't have that kind of dichotomy. So yeah, it's called Manhattan. Do you want to guess why it's called Manhattan? It is the Manhattan Project. Anyone? Yeah? The grid, exactly. So in computer science, anything that's a rectilinear distance, you can only go up and down or left and right. We call that Manhattan distance, named after the city, the island in the city of New York. It's also the birthplace of process-based music, or minimalism. So Steve Reich basically started thinking about music not only as notes, but process on the island of Manhattan. And that's what I'm trying to do here. I'm trying to get music so that you can write it and express it as patterns as well as process. So yeah, you open up the cell, and just like in Excel, you can stick in formulas that define the pitch, the volume, and all that jazz and all that good stuff. The data is visible, the code is hidden. It's quite easy to see it. The relationships between the data is all there, and it's scalable. It's just like Excel, and Excel is the most successful end-user programming language in the world because you can use it as an end user, and you can write one line of code to do something useful. And so you don't have to, like C++, I have to what? Before I can actually print out hello world? You're kidding me. I'm going back to Excel. So that is it. It's all about this continuum, and it's all about the continuum. If we do this, we open up the ability to have the aesthetics that you can pursue in like DAWs, and the kind of expression abstraction that you can pursue in code. Right. That's, I'm going to leave a very quick demo because I catch myself monologuing. So let's actually load the thing. So first of all, it's free. It's on Steam. Just type in Manhattan and you can download it for free. And there's a lot of things in the program, like examples, guides, as well as a complete curriculum on how to learn programming through music. But just to give you one very quick example, you need a piano sound. Ooh, and that is not the right audio settings. It can go very fast. We're on headphones. Loud headphones. Ooh. Right. I can write music. I can do things like loops, which we can do in music, so that's fine. And then I can make it slightly more interesting. So maybe it's a random pitch between D sharp 5 and E5. And then I can make relationships between different notes. So this might be the same as, 4 rows back. So I'm not going to give a big demonstration because I don't have the time. I can walk you through the program a lot more downstairs. I want to move on to basically how this is used in games. And so the game we're talking about, Ars Arcus, is available as downloadable content on Steam for the Manhattan app, and it allows you to experience the game. But the score for it and the project for it and the code for it are all in the program as well. So I'm in two minds as to which way I introduce this. So I'm just going to go with the score first. So yeah. This is the menu music. Now you're in the game, but nothing much is happening, so we just got some procedurally generated tribal drums. And nothing will happen until the game says, oh, there's a threat, the tension rises. And you see over here, we've got this tension variable, which is currently 0. If a new attacker appears, that'll go up. And he says, all right, I'll just put it up then. Okay, it's not too bad at the moment. You've got some attackers marching towards you. And there's 2 of them. Another instrument comes in. And what I'm demonstrating here with the use of a familiar tune is you can just write it manually. You don't have to think about the process that went into writing Johnny Comes Marching Home, or write it as an array. And then eventually it kind of builds up in tension. But if I go back to just the piccolo, in fact, I'm going to demonstrate this in the game. Right. So the game is downstairs if you want to play it, and there are 2 modes to it, basically. And I have demonstrated this before, so I'm going to be quite quick about it. So to demonstrate the kind of integration between the game and the soundtrack, I put the orchestra in the game. You can see them playing each of the individual notes. And bad guy's about to turn up. There we go. And when I kill him, there's going to be a bell in key with the music and a drum in time with the music. It would be a guy with armor, wouldn't it? Anyway. And again, to demonstrate that the music is being written as the game plays, and therefore you can do basically anything with it. But he's got dropped about 5 grades in playing ability. And for that reason, his services are no longer required. And actually, whatever. Right. Do come downstairs and explore some of the other concepts. And what I've done now is I've released this plugin along with a sample scene and documentation. So it's currently going through the Unity Asset Store review process, but I'm going to give you all a copy. So if you're interested, you want to try it, you want to help me beta test it, just come up, ask for my email address at some stage. Just ask for the thing, basically, and I'll send you access to it. But basically, it's over here, and whereas Unity is playing. Here we go. And so there you've got, I play that. going to think about it for a while. Okay, you're being too slow. This is valuable time. Here's one I made earlier. With a vaguely recognizable tune. But then basically, because the tune's not set in stone, we'll be able to do things with it. We'll be able to vary it, change the key of it, change the speed of it, whatever we like, basically. There we go. No, that's the PowerPoint slide. I think there's too much going on. I am running Unreal in the background with the next example. There we go. Where'd they go? There we go. So the soundtrack is communicating all the notes to Unity, so you can see them being visualized in the 3D environment. So you can do whatever you like with that kind of information. We can change the instrument that's being played on. We can change the key at the right moment, so we have to wait until it's just appropriate. Or, you know, this really needs an almond break, so let's go for the variation. Again, just at the right time. And it's just a matter of community. You can make variable changes, and just Unity says, change this variable to that, or run this code. I think I was channeling the Futurama theme at that stage. Right. I've lost PowerPoint. There we are. So yeah, and basically the documentation and the example scene will walk you through how to use all this stuff. It is pretty straightforward. And you can also use the Manhattan editor alongside the Unity editor and edit the code for your soundtrack as well as the code for your game live as the game runs, which allows you to really easily play with different ideas. Right, come downstairs and play Arzakis. It is developed basically as an exploration ground for different soundtracks, and they got all of these different mechanisms in the game, including a lot more downstairs, such as, for example, when you get into the castle, you can't actually see the attackers because they're in the streets, so you have to listen to the music, as basically the pitch goes up as they get towards you on the scale, it's in tune, but also they change instrumentation, so nice, calm pizzicato, arco, tremolo, and then full orchestra, percussion, and death. Thank you. Oh, 5 minutes. Yes, that's true. So, right, that's basically spin on. Procedural audio, I'm trying to do the same thing. So this other game I've developed does have a Manhattan soundtrack, which reacts to what's going on around you, and yeah. So I'm just idly cycling around easily, but if I pedal a bit harder, and there's lots of different mechanisms that will be used in this game. Notably, the game will start out as a wasteland with a kind of dystopian soundtrack, and then you'll add harmony to both the landscape and the soundtrack. But in addition to the music, the sounds of the game are also synthesized. So this is using the procedural audio techniques pioneered in 2010, basically, and not used that much for 2 reasons. It's slightly heavier on the CPU, which is not an issue anymore because CPUs are too fast, and the uncanny valley, which is still don't sound quite as realistic as samples. So you need something, you basically really need to work on the sound. You need to be able to kind of write code while hearing the sound. running on my poor little laptop, bless it. There we go. Slightly easier to hear the slightly louder Harrier jump jet. And this wasn't actually a feature I was intending to put in the game. Because the game is literally the size of Britain, I needed a faster way to get around. So things like the wash off the ground and things like that, the gears, and then the speed of going through the air. So I go horizontal. Very reactive and very immersive. And the idea, well, the key thing is basically to tune it. Where did it go? Thank you. It was supposed to go. So one of the key things basically is, and let me spin on to is this. Yes, there's a lot of this talk. I'll have to deliver it another time. Which is basically the ability to write C++ code, which is doing the procedural audio, and hear it at the same time. So this is basically a plugin that you can use in DAW to generate synthesizers and effects and procedural audio sounds. And basically, you can edit the code of the running plugin. So you can change the sound and tinker it just a slight bit, hit rebuild, and you'll hear the change in the tone. What you can also do, and this has been very useful in kind of translating some of the pure data patches, is I can feed the sound of pure data as an input to this, have it plot the input and work on my sound separately so I can compare the sounds. And you can do this with the Harrier jump jet recording and things like that. So you get to see and hear the sound you're working on, and you're never that far away from knowing what it does. The other really key part of this is that pure data is programming data flow language. So Klang is an extension for C++ that adds audio syntax and semantics to C++ and allows you to express it as data flow. So it's actually really easy to go from a kind of flow language to C++. And one of the interesting things is I'm currently, so I need help with this, thank you. I'm going through all the process of turning all of these pure data patches into C++ examples. I'm going to open source it. But also, in some of the cases, I'm taking two approaches. I'm either writing the best possible sounding version of it, or I'm trying to be as faithful to the PD version. So I'm actually also adding some of the PD primitives to the Klang language so that you can just use those. So yeah, please come downstairs. All of these games, technologies, and things like that are on display. There's a lot, obviously, I haven't talked about, but it's all free, and I'm really keen to get people on board designing sounds, coding sounds, and also telling me what works and what doesn't work, because I'll change it. Thank you very much.
Thank you.